Okay, and today we're going to be talking about sketching angles. So first you have to know we are going to be sketching angles on a coordinate plane. So you have to know what quadrants are and origin and all that stuff. So quadrants, hopefully you understand, are the four sections created by the axes, by x and y axis. So you have the two axes, this and here, and they create four little sections. The origin is that spot right in the middle where the axes meet. And name the four quadrants. Well, we know when we talk about the quadrants, we talk about them in Roman numerals, and I forgot 3. So 1, 2, 3, and 4. They go in a counterclockwise way, and they form a C, like coordinate plane. 1, 2, 3, 4. Okay. Now the next thing we're going to be talking about in that quadrant, in that coordinate plane, we are going to be sketching an angle. And a few things you have to know is that the vertex is always at the origin. So the vertex of an angle is where the two sides meet, to the two rays basically meet. The initial side is where where the angel begins, is on the x-axis, and it's the positive x-axis. This is the initial side. So that side is always there if this is a standard position. Okay, that's important that you realize that we are talking about, we can sketch an angle anywhere, but when it's in standard position, it's on the positive x-axis. The terminal side is where the angle ends. So here the terminal side is there, and as you can remember, it is in quadrant 2 in this particular angle. And we do draw this little angle arrow here to know if it's a positive or a negative angle. To determine the quadrant the angle terminates means where does the angle end? Where does the angle end? So we're going to see these determine where the quadrant the angle terminates quite a bit. Not today, but soon. So rotation about the origin. So I'm going to try to use this fancy thing I have here. So if we go counterclockwise, counterclockwise is a positive angle. And it's always counterclockwise from the x-axis. So we always it always starts right here. And if it goes counterclockwise, it's positive. If it goes clockwise, it's negative. And I mean that the terminating sides. And quadrantal angles are angles that are on the axes. Okay, so let's just talk about that for a second. I'm going to try this first. See how this works. Look at this. That's not the coolest thing. Okay, this is your x-axis. This is the positive x-axis. We have this little arrow here that's going to show us the one side, the beginning side of the angle. The vertex is on the origin, and then when it goes this way, this is a positive angle. So as I go this way, these are all oop, hey, how's that going? This is all positive angles. All right. So from here to here, that's a positive angle. Now if I start here and go in the negative direction, down, that's clockwise, that's considered a negative. So I can draw an angle like this, and if I go like this, that means it's a positive angle. And I can draw an angle like this, but I have to show that it's going from here to here, that's a negative angle. I'm going to talk about that a little more in a second, but there you go. So what are the quadrantal angles? I did forget to answer that question on the bottom there, but we're going to talk about that now. So hopefully you realize that all the angles start here. And if I go right here, that is a quadrantal angle, so that's 90 degrees. It's a right angle. Right here, all the way. If I go, I'm not going to use the lightsaber this time. If I go from the x-axis all the way around to the negative x-axis, that's 180 degrees. And down 270. And this one right here would be 0 if we didn't go anywhere, or if we went all the way around in a circle, that's 360. I'm just going to erase this one. I need this space a little. So what we have here is some of the angles. So if I go from here to here, that's between 0 and 90, and that's in our first quadrant. So that's what I'm asking. What degrees are in the quadrants? Well, this is quadrant 1 right here, so all the angles between 0 and 90 are in that quadrant. So if we call it theta, between 0 and 90 degrees. Notice I don't have the line underneath it because the quadrantal angles are not actually in the quadrants. So quadrant 2 goes from here to here, so that's between 90 and 180. That's quadrant 2, but the angle, mind you, would go from here all the way over to there. So then finally, if I have a, well, not finally, but almost finally, if I have a quadrant 3 angle, let's say goes all the way to here, it could go anywhere all the way up to 270. So that would be somewhere between 180 and 270. So we're just talking about what if my angle terminated in quadrant 3, it would be somewhere between 180 degrees and 270. That's what all I'm trying to get across here. And then finally, quadrant 4 would be somewhere between 270 and 360. And I lost the little less than symbol. Okay? And that's the wonderfulness that is the quadrantals and all the angles that they fall. So coterminal angles are angles that have the same terminal side. That says terminal. So we have an angle of 120 degrees here. From here to here, that's 120 degrees. And that's in the positive direction. If I went in the negative direction, this angle also has an angle of 240 degrees. I mean, a negative 240 degrees also ends at this spot. I could also take this and go around 17 times and end right there, and that would also end at that spot. So the basic idea is we know 120 has something that's coterminal is negative 240. Hopefully you realize that, because it's in this picture right here. All you have to do is either add 360. Basically, you're adding a circle. If I'm here at 120 and I add a full circle, go all the way around again, I'm going to have something that is ending on the same line. It's a simple concept that I'm not getting across very well, so we'll see how that goes. So I either add 360 or subtract 360 to find another coterminal angle. It's 360 degrees. So if I do 120, I can subtract 360 and I get negative 240. I could subtract 360 again and get, I don't know, 600, negative 600. There's another one. This is messy. So negative 240, 120, 600, these are all coterminal. If I add 360 and go the other way, 480, I guess would be that, and so on. So just adding or subtracting 360 is the route to take. So see if you can determine right here if it's 37, negative 37. Circle the ones that are coterminal to negative 37. Okay, I don't know if it was genius on my part or just really stupidity in general, but I didn't find any. None of these are coterminal. All you do is you add 360 to negative 37, and I get numbers like 323, positive 323. That's not negative 323. Add 360, and I get 683. These numbers are coterminal, positive. but the other ones aren't. And then if I take negative 37 and subtract 360, I get negative 397. I can subtract 360 again, and I get negative 757, but these are not any of the ones that are there. None. I don't know if I'm a genius or not very bright, but whatever. So sketch the following on the axis. So the way I do this, it doesn't have to be perfect, but you have to draw the terminating side. So we all understand that the positive x-axis, this one, is the initial side. The terminating side, you just have to get in the right quadrant and basically pretty close. So 65 is going to be in quadrant 1, so it's going to be probably about here. It's a bit more than half. And then you do have to go like this, and and draw that little arrow showing that it's going in a positive direction. Okay, so it's just going from this part to there. So if I do negative 115 here, negative 115, this would go to negative 90, negative 180, negative 270, and negative 360. So negative 115 would be somewhere in here. And I have to show that it's negative, so I go to there. So this angle, starting at the x-axis and going down, that shows that it's a negative angle. Starting at the x-axis and going up, that's a positive angle. Okay, if we do something that's over 360, what I like to do is figure out what is the coterminal angle that's in between 0 and 360. So I simply take it and I subtract 360 in this case until I get to a number that's between 0 and 360. So I get 210. If I subtract 360 from here, I get 210. So the angle would be, so this is 90, oh sorry, this is 0, 90, 180, 270. So 210 is somewhere in here. So I'm going to draw my angle, my terminating side. But we do have to account for the fact that it went around a circle once already. So I have to go, and I have to do a little squirrely thing, and I have to go around, say, okay, that's 360, but then it went around another 210. That's a little messy, but that's just how it is. So that would be 570. You have to show that it goes around that little, the circle. Negative 390, some people don't like to deal with negatives, so you can keep adding until it's between 0 and 360. I don't like to do that. I can deal with the negative 30. I simply add 360 to it, and when I do that, I get negative 30. So this is 0, this would be negative 90. So negative 30 would be right about here. And so to draw this, I have to go start at the x-axis and go down. I have to go all the way around negative 360 and then another 30. So that's how we draw when the angles are bigger than 360 or less than 360, I guess. You have to show it doing a little swirly thing. All right, have a good day.